Brianna, show us the linkage mechanism. So this, turn it on. Why don't you turn it on and show how it moves up and down? So it moves up and down. Okay, and the way that this happens here, so this is the part that actually pulls down on it, and this is attached to another linkage, right?
Yeah. The other linkage is attached
through this.
Right here. There's these things. They have a pin down below that the linkage attaches to. And you can see this linkage is this odd kind of triangular shape,
So
which attaches to this cylinder right here.
Yeah. So long cylinder here, attaching
To the point right there.
down there. And so there's this triangular shaped linkage and what, like two pins that...
That's what these pins hold. There's another pin down here that attaches to the linkage, and that just holds it to the machine.
Okay.
So there's nothing welded, which is really nice, because if any of this messes up, you can replace it. I mean, this is an expensive part. I had it cut for me. It was $55 for one of these. And so, but that's not that expensive. If it breaks, you can replace it.
For one of what?
One of these funny shaped little plates right here.
Yeah. Okay. And this is the main linkage arms that we saw in the other video.
Yeah, it's the
Equivalents.
vertical linkages. I kind of named everything. It's one of the beautiful things about being a prototyper is you can name whatever you want.
Okay, that's the vertical linkage, and this is the pivot linkage here. You call it that, or?
Well, I call this the main pin holder because I feel this is the main pin. This is the upper arm. Main pin is just what this big arm pivots about. So main pin holders, these I named linkage pin holders right here because it holds the pin that attaches to the linkage. That's some of the names.
Yeah. So in our version, we've got the angle shear. And
Yes.
the OSC version. Okay. You want to tell me a little bit, so what all are the blades that are required in this machine? So we've got the shear blade.
Yeah,
which,
let's see. So you can see the shear blades from the back side better than the front side.
So
There's one blade that mounts up here. They all mount with these Allens. So I'm getting the Allens that are this size. Same thing here. And they mount.
wait, turn it on and let's see it because it's down position. So
Yeah.
so let's. So you've got this upper blade. bolted
No,
on with the Allen bolt?
there's one upper blade here. That's this one, and then this is the bar shear here. So that's separate. I'm not including the bar shear with this model, but there's room to mount it. So I made it a little longer. This table is longer so that you can retrofit the bar shear if you'd like.
Okay, well here, so we've got the bottom blade of the shear,
Yeah.
and it's only what, like 2 inch, like 1.5 inch or something like that.
1.5 tall by 3/4.
And then the upper blade, this one. So there's 2 blades there.
Yeah, and they're the exact same thing, and you can use all 4 sides of this because it's perfectly symmetrical. So you can, if this side dulls, you can take it out and rotate it and use another side.
So are you actually getting the blades from this is Roger Olson? Is he shipping them
No,
over?
he sent me one that was the lower angle blade, which is this right here. It's different in my model because it's longer and different shape. But that's that right there. There's 2 of those.
This blade, so how thick is that? How thick is this blade?
Ouch. It's 1 inch in mine. I don't know what it is here. I'm just using the standard
Looks
blades
like
from
that's a
Piranha.
2-piece, so that's one.
Yeah, it's
here
2
it's
pieces, so that way you can rotate it and use the other
And-
sides.
Okay, and you've got the same style in yours?
No, they're different shape. You can use 4 sides on those. This you can only use 2 sides, so it's higher quality.
So it's in 2 pieces, just like here.
Yeah.
One side and the other. Okay, excellent. And then
And then this blade up here, the upper blade, it can pivot. It's kind of hard. We don't really use the angle much because this angle shear, the clamp doesn't work very good, so it shears kind of funny.
so in your design, this also pivots?
Yeah, it does in this too, and that makes sure the cut's clean and sharp and all that.
And then on our back side, we don't have anything right now,
No,
right?
it has capability of, but I'm not installing a Cooper notcher, so
Okay.
you can retrofit it. And the reason I made it retrofittable is because if we weren't doing that, I mean, you would essentially just have this arm going to this point here, and then nothing here. That's, I don't know, 6 to 8 inches of material. But this whole arm assembly is going to cost like $800. So if you want to retrofit it in the future, you would need over $800 and you'd have to remachine this whole piece to be able to retrofit, whereas I'm keeping it as is and you won't need to pay the extra. It's only maybe like $50 extra in the beginning to add capability of retrofit.
How? By allowing for what you cut out that spot for it in the first place?
Yeah, I made, you can see this shape, it comes down here. I kept this in my design so that this comes out. I haven't designed a table or anything, but basically there's just those there. So if you want, what you would need to do to retrofit, so you need to mount a table here with supports because there's a lot of force operating at this point, and then just machine this. Oh shoot, I need to do that. I don't think I did that in my CAD. I forgot to add that because I was considering, because I can have them laser cut this so it's more accurate, so you won't have to do so much machining later on if you want to retrofit, which is what I should do. But yeah, you need to buy the blades, tap some holes in the bottom for mounting it, along with like down in here you're going to need to figure out something here. You're going to need to machine away these arms. See these arms? It's shaped like this. You can see it's machined away that ½ inch or so. You're going to need to machine that away so you can mount those, as well as tap a hole so you can mount them. But yeah, they're just retrofittable.
Okay. And on a hole punch element, are you allowing for like this interchange like this here? No.
Yeah, I'm allowing that. Yeah. And that's the only way to do it really, because the way our punch system works, you're going to have to remove it if you're punching really thick material because it won't go all the way up. Or if you're shearing really thick material. And basically to remove it, the punch has a piece that's just going to have a hole drilled right here. You're going to have 2 linkages with like a bolt that attaches it, and then down below there's a kind of a big thing that presses. It's got a shaft where you mount the punch nut and can just push down. There's a stripper on it, and there's a guide that's going to attach to here with some bolts. So it's attaching in there. The guide's going to hold it in place so it doesn't wobble and so it goes perfectly in the die.
So this kind of piece for...
This is for braking.
For braking, we'll have that capacity with ours?
Yeah, we'll have that capacity. And it's also going to be compatible with any Piranha tool. You'll just need to get this dovetail and machine it properly. And then any Piranha tool you can put on it. You will have to be considerate of the capacities. Like, you can probably put on 120-ton stuff, but I don't know that it would work to its full capacity if you're putting that on here, because this is going to be a 90-ton.
Okay. Yeah, excellent.
One thing I should probably say, too, is how I'm making it 90 tons, which is basically, I'm using a design very similar to this. I beefed up these arms, made it thicker, made this stuff wider, did a few basic calculations to ensure everything's going to be thick enough. And then linkage and stuff is the same, but they're using a 4-inch cylinder operating at 2,600 tons, or 2,600 PSI. So what I did is I took that out, put in a 5-inch cylinder, which gives you much more tonnage, and operating at 3,000 PSI, which gives you pretty much 1.8 times more power, which means, you know, instead of this is a 50-ton machine, 50 times 1.8 equals 90. So that's how I get the capacity.
All right. Excellent.